Okay, so what are these? Well, these are things that look like x to some power, x to the y, okay? So we call x the base and y the exponent. Okay, and they each play a different role, as we'll see. So just as some examples, we could have something like 4 to the x squared. This looks a little strange, but in this case, the base would be equal to 4, and the exponent would be equal to x squared. This looks a little strange because this is itself an exponential, but it's perfectly legitimate from a mathematical standpoint. Okay? Something that I think is kind of helpful to think about what was the role of the base and what is the role of the exponent is to look at the following. Right? If we look at x squared versus 2 to the x. X squared is a polynomial, and it has the variable in the base, and the exponent is constant at 2, versus 2 to the x. This has a constant base of 2, but there's a variable in the exponent. You might think this doesn't matter very much, but it makes a huge difference in terms of how these functions behave. In particular, we can look at something like the plots of these things. So I think it's always helpful to know what they look like. X squared looks something like this. Okay? We've already looked at functions like this. 2 to the x looks very, very different. It looks something like this. Right? It grows very, very rapidly, and in particular is also not symmetric the way that x squared is. So this is x squared, and this is 2 to the x. Okay, so very, very different, whether the variable is in the base or the exponent. Just a statement of nomenclature, when someone says an exponential function, they typically mean constant base, variable in the exponent. If there's a variable in the base and a constant exponent, this is what we call a polynomial. So they are somehow related, but behave very differently in most circumstances. So we'll look now at some of their most important properties.